In this video, I'm going to be talking about friction on an inclined plane. So let me draw a ramp. And let's say there's a box on top of this ramp. The force downwards like this is just going to be the weight, which is mg. And let's break this up into its particular component forces, which are the force parallel to the surface of the ramp and the force perpendicular to the surface of the ramp. And this angle I'm going to be calling theta, this angle gamma, and it's going to be 90 degrees just for the purposes of this video. It's not actually going to be that probably most of the time. But for the purpose of this video, we're going to say this angle is equal to theta. This angle is always equal to theta. And this is why I put this 90 degrees here, because if we see, if you translate this angle, this line right here to right here, we see that this angle is 90 degrees. And this is gamma. So 90 minus gamma, right here, this is 90 minus gamma, is going to be equal to theta. And we know that because if you start off with 90 plus gamma plus theta is equal to 180 degrees, let's say we start off with that, and we get this equation right here. If we add gamma to both sides, and we add 90 to both sides, we get back to where we started. Okay. So this angle right here is equal to theta. Okay. So let's solve what is the magnitude of the parallel force and a perpendicular force. If we start off with the sine of theta, we get that the angle theta right here, the sine of theta, is equal to the opposite, which is the force parallel, divided by the hypotenuse, which is just the weight, or mg. If we multiply both sides by mg, we get that the force parallel is equal to mg times sine of theta. Now if we start off with the cosine of theta, we know that the adjacent, which is just the force perpendicular, divided by the hypotenuse, which is just mg, and we multiply both sides by mg, we get that the force perpendicular is equal to mg times the cosine of theta. Okay. Now, let's say we want to solve for the acceleration. First, we must know that the frictional force, we're going to take kinetic frictional force. The equation for kinetic friction is going to be equal to kinetic frictional force divided by the normal force equal to the coefficient of kinetic friction. Multiplying both sides by the normal force, we get this right here, which is the kinetic frictional force. We can also do this with the static frictional force. But what is the normal force? If the box isn't accelerating perpendicularly to the surface of the ramp, then the net force, the forces must be balanced, and this normal force must be equal to this downward component force right here. So the normal force is going to be equal to the perpendicular force, which is mg times cosine of theta. So let's say we want to solve for acceleration, like I was just saying. We must know that acceleration times mass is equal to the sum of all forces, which in this case is the frictional force, kinetic frictional force, which is UK, U sub k times F normal, which is the kinetic frictional force, plus this parallel force right here, which is just the sine of theta times the weight. Well, if we know the sine of theta times the weight, if we know the parallel force, we know the kinetic frictional force, we know the mass, we can solve for the acceleration by dividing both sides by the mass. And we get the acceleration. Also, whenever this angle theta becomes 0, the perpendicular force, which is mg cosine of theta, becomes just mg. In other words, whenever this right here, this box is on a flat surface, when the angle becomes 0, cosine of theta is going to be 0, and remember cosine of 0 is just 1. And then it'll just be mg times 1. So the force perpendicular right here would just be the weight.